Hello, everyone. I decided since we were so rushed in class yesterday that it would be worthwhile to record this short tutorial on how to approach the long-term capacity planning, or as the subtitle here says, how to analyze the problem and solve it when we have forecasted demand greater than capacity. So I'm going to pick back up as if you were in the lecture yesterday and at least absorbed a little of the material that was there. So proceeding with that, one of the first things that I want to talk about is the chart that we had that looked at what we're considering to be the forecast with leeway. If you need to go back to your PowerPoints and look at how we arrived at these numbers, you should be able and capable of also computing these if you were in such a situation. We just simply took the forecasted demand, if you recall, which came out of that long-range business plan. So remember, that's marketing, sales, finance, and even a little bit of supply chain. And in this case, we are applying that 10% leeway to that. So we want to be able to look at the variability of demand for this product category over a period of time, and that 10% leeway reflects that amount of variability in that demand. We said in lecture on Thursday that that could be 10%, 15%, or 20%. So please make sure that when you're doing this type of problem or this type of analysis in your job, that you understand what that leeway needs to be. So this chart is for North America, Latin America, Western Europe, Eastern Europe, we said the Middle East, as well as Africa, and then Asia. So this is the chart that we were given because it was already calculated for us. Now, the next thing we looked at was the global production. So you'll see here that in many cases, and we're also specified in the parentheses there where these plants are. For example, in North America, it's in New Jersey. And you would note here that in Eastern Europe, it's in Moscow. And we're told, which line it is. And we talked a little bit about the line numbers and how they tend to be in a sequence or a type of series that's really very consistent with that region. So typically North America is going to have the single digits, and you'll notice that in terms of Asia, that by that point in time, we're up to about number 50 in terms of our line. We're told what line type it is. And we're also given the demonstrated operating efficiency for those plants. That would be something that you would be given for these particular operations that are up and running. And you'll notice in this problem, much like your homework, we've made it fairly simple in the sense that the current schedule is 24 hours and we're operating 5 days a week. Proceeding with the in-class exercise that we did, we talked about the fact that when we have a gap, in other words, when our forecasted demand with leeway is greater by more than 100,000 cases than what we have current capacity, we've got to solve for that gap. And we have a number of options that we can use to solve that gap. We talked about these yesterday. I'm not going to repeat that particular lecture, but you'll notice here that we have 6 things of which do nothing, and there's no cost affiliated with that, is obviously one of the options we have. And we said that the one that we do not want to use unless we absolutely have no other options would be number 3, which is a cross-region supply. So let's start where we left off last time in terms of the production chart. You were asking the in-class exercise to get familiar with how we would absolutely do these calculations, and you were asked to do it for the 5-day and the 7-day operations for both dedicated and flexible for the 75% operating efficiency. Now, I will post the solution for the in-class exercise so you can also go back and check your work and work through these numbers to make sure that you know how to do them. But when we solve for that 75%, we got 0.86 for the 5-day dedicated. We got 0.79 for the flexible for 5-day, and so forth. Now, you'll notice something else about this chart, which I think is really a very interesting and clever way to approach that. I might suggest that much like we have here, that you go back to one of the previous charts, and I'm going to move back to that in this talk here, where you'll see that North America has 85% demonstrated OE. And you'll notice that in that solution, we've also brought that across. So we know that North America is 85% operating efficiency along with Western Europe. That just gives us one less table to have to check because there's so many moving parts to this type of analysis. And so I might recommend that you do this when you're doing your homework and also during the exam. All right, so moving right along in terms of the in-class exercise, the next thing we were asked to do is to determine what is our demand with leeway compared to the demonstrated capacity. We've chosen for this particular analysis to compare those. So the demand leeway is going to be the first number. So let me pick out an example here. Let me move up to North America. Our demand with leeway is 1 million cases. Our demonstrated capacity is 980,000. Those are just simply looking up from the previous tables that we had. And let's make sure that we understand where those are coming from. So give me a second here, and I'm going to go back to a previous chart. And if you notice, for the current year, North America, for the SKU family A, we have 1 million cases is our forecast with that leeway incorporated. If we also look at where they are, because they're 85% operating efficiency, our current capacity is 980,000 cases, or the 0.98, since it is reported, or to keep the numbers reasonable, we're also reporting them in millions of cases. So that's where those two numbers came from. 1 million cases is our demand with leeway, and the second number is going to be our demonstrated capacity, which is 0.98. We are not dividing those numbers. Let me say this again. We are not dividing those numbers. We're simply comparing one to the other. So when we fill in this chart like we did in class, you'll notice that for Western Europe, we've looked up those two numbers. We looked up the demand with leeway, and then off of the chart where we filled in that component for, I think we did it for 75% operating efficiency, we were also able to see, based on current operations, what the capacity or the operating efficiency is. Now, once we have the tables filled in, we're ready to do the hard work or the heavy lifting. Let me suggest that the next step in this is to simply, as I said yesterday, either circle or highlight the years and for each region where we have more demand with leeway than we have capacity. You'll notice here that in North America, that happens in year 2. In year 2, our demand with leeway is 1,100,000 cases, and yet we only have capacity for 980,000 cases. That's greater than that 100,000 cases that we said that we're willing to live with in terms of the differential, because remember, it's a forecast. And so if we set that limit of that 100,000 cases difference, that's where we're going to need to plan to add some capacity if it's greater than that. In my case, because I had the spreadsheet or the Word document, and you'll have that as well, I highlighted each region for each year where that gap was more than 100,000. And hopefully, if you do the same, then you'll get the same sort of picture that I have here. Now, it's important because as I start moving through this, so it looks like North America, Latin America. If you'll notice here, Western Europe doesn't need anything done at all because we never reach a stage or a state where we have more demand with leeway than we have capacity. Even in our projected year 5, we only have demand with leeway forecasted of 800,000 cases, and we still have the ability to produce 980,000 cases. So we're in good shape in terms of Western Europe. In Eastern Europe, however, it looks in year 3 that we start to run into capacity issues. In the Middle East and Africa, in year 4, there begin to be capacity issues on a long-term basis. In Asia, almost from, I would say, the very beginning in terms of looking at that, we know looking out from year 2 beyond that they're going to grow at really a very significant rate. So the heavy lifting begins when you decide, how are we going to solve these problems? So let's look at the next part of this. In North America, based on that list of 5 that we have, your job in doing this analysis is to figure out, how do we solve those long-term capacity problems with the least cost investment? So I'm going to say that again. The goal is to optimize the investment to be able to meet that forecasted demand. Because remember, once we've signed off on that long-range business plan, It is up to the supply chain to deliver the capacity that's needed. So in North America, for example, because it takes us a year to implement any operating efficiency, we're going to move from 85% to 90%. That is an inclusive one-time cost of $2 million. So we've noted that in that column. And then by the time we get, and that's going to go into effect in year 2. So that's definitely going to help us when we have that capacity gap there. And then in year 3, we're going to move line 1 to 7-day operations. And we said that that's going to be a recurring cost of $5 million per year, because remember, we're doing that because we're paying overtime, and that's going to help us meet the capacity gap for that particular one. And remember, that's going to be in effect the same year. So in year 3, we ask people, would you work overtime? They tell us yes. Those costs start immediately, and we also get that improvement immediately as well. I'm only going to pick out a few examples here in terms of getting you ready to do the homework. You'll notice in Western Europe, even if we're doing nothing, please list all of the regions on your solution set, because in Western Europe, we don't have any gaps between the forecasted demand with leeway and our available capacity. So we simply put there, do nothing as the decision. Now, the last one I want to talk about is Asia, because it directly relates to the last part of the analysis that we're doing for long-term capacity planning. And that involves what we're going to do, because remember we said that by the time we get to looking at what's going to happen in year 3 and beyond, we have a very significant growth in terms of the demand. And we actually have a gap starting in year 2 to try to take care of that. So by year 2, we have to have something in place. It's going to take us 2 years to build a dedicated line. And if you look at what's happening for that SKU family A and B, they're both growing at about the same rate until we get to year 4 and 5. And so that investment in a dedicated line is definitely something that's going to be worthwhile. And in fact, if I looked at all the other options, whether it's an improvement in efficiency or whether that's looking at converting, we already have the dedicated lines. Whether or not we want to convert for year 2 to a flexible one, that's not going to solve our problem. And certainly the 7-day operations may be an option, but for the long term, we really need to get that additional capacity up and growing or up and going. And so that's why we're going to put that line in the current year. We're going to say, let's build it. It takes us 2 years to put it into place. And there is a $50 million cost, the one-time cost of putting that into place. Now you'll notice in year 2, because we also have so much going on, we're going to also say that we'd like to build a flexible line. And there is a cost for doing that of $50 million as well. So whether it's dedicated or flexible, we still have the same cost investment. But if you look at how much that particular market is growing, we think that it's well worth that investment. So if we do that in year 2, then it's going to be up and operational in year 4. Now, in year 5, if you think what happens, we've got the flexible line into place. We're going to move those 2 lines then to a 7-day operation. So the new one that we built in terms of 51, that's going to be that dedicated line, as well as the original line that we had. We're going to move those, and that's going to be a $10 million cost in terms of converting those particular lines over, and that's going to be one that we have to take into account. In year 2, to help us also in year 3 take care of the demand that we need, we're going to increase our operating efficiency by 10 points. And so when we increase that operating efficiency, it costs us $2 million for each 5% increment, which is why we have the $4 million. So if we look at how all of these play out, then for Asia, we're asking that you actually do the math or the analysis to assure that we have the capacity that we're going to need. So you'll see what happens in terms of some of our decisions that we have here. In Asia, we said that we wanted to build that dedicated line 51. We said that if we make that investment in the current year, that it's going to come into play in year 2, and certainly it has done that. And so we took our capacity from 0.79 to 0.86, and that certainly is going to take care of that shortage or the gap that we had there. We also said in terms of Asia that what we want to do is that we want to build a flexible line that we're calling 52. And what that's going to do is it's going to take care of all of our capacity that we need for both of those. So if you look at that A and B in year 4, because remember, if we build that flexible line, it's not going to come into play. If we ask for the funding in year 2 and we get it approved, and then we put that into place in year 4, we're going to end up of demand. If I add that 900,000 cases and the 700,000 cases, that's roughly about 1.6 million cases that we're going to need in capacity. And it looks like the 0.98 that we had in that dedicated line that's already into place. And then a new flexible line is going to add 900,000 cases. We're definitely covered there. But you'll notice, because demand is still growing at a very significant rate, that we still have to do some other things. So in year 5, we're going to move to that 7-day, or what we consider to be that, it's going to be the line 50, as well as we're going to move 51. So I misspoke earlier when I said it was line 5. It's actually line 50 that's going to go to the 7-day, as well as line 51. Now, this is really kind of, I refer to this as kind of the brain teaser, because we have so many options to solve these problems. You'll find that we don't always have the same solution. However, I think that some solutions make more sense than others. I don't think that in reality that you're going to keep looking at operating efficiency improvements every year. That's going to take care of that. Nor would I think about overtime for a sustained period of time solving the problem. Certainly it will for perhaps a year. 2 may be stretching it, because after a certain point in time, people really value that time off. And so I think we have to think about some other options. So if you think about this, you put on your logic cap and try to think about, is this a sustainable solution, particularly if we have growth? And remember, it's a forecasted demand. And at any point in time, the larger the investment, we'd want to look at that trigger to make sure, do we want to build a line? And some of these, in terms of the operating efficiencies, will always work for us. So like I said, they're all trade-offs. And as I said, the in-class exercise looks a lot like the homework. And if you have any questions, please let me know. And I hope this short tutorial in terms of how we would approach this problem will help you have an easier time approaching the homework.